Okay, guys, the next chapter is called differentiation. First, I want to give you the definition for differentiation. What is differentiation? Differentiation is the ratio of change in the average value of the function f to a very small change in the value of x. To understand this, please take a look at the graph below. So I have this graph of fx. If I take x as a value of the x in the curve, and I give a small change of x, I call it a, then I will have this new value of x, which is x, right? And then the value of y. If we calculate the value of y for the x, I will have fx here. And then if we calculate the value of the function for x plus h, I will have x f x plus h like that. And the definition of the differentiation is the ratio of change in the value of f. So that means the change of y. The change of y means fx plus h minus fx. Ratio means over the change of x. The change of x is x plus h minus x, which is h. So this is called differentiation. Okay. And because of the value of x is changed at a very small value, we can say that the change of the value of x is near to zero. We are very close to zero. Or in this case, h is approaching zero. Note that we have the word approach means limit. So actually, differentiation is a form of limit. For the graph, the differentiation of fx, for this graph, the differentiation of fx is limit limit h approaching zero from the difference of the value of y, fx plus h minus fx, over the change of x over h. So this is the definition of differentiation as limit. Next, further analysis. From the definition of differentiation above, we can know that the differentiation of a function also acts as the gradient of the curve at the value of x. Let's look at this graph. As you can see, this is the previous graph. This is the curve of fx. And then if I take the change of y over the change of x, it's also called the gradient, right? You know that the gradient is the change of value of y over the change of value of x. So we can say that the differentiation also the gradient of the curve. Okay, that is the definition of differentiation. Next is real life application of differentiation. With the help of differentiation, we were able to find the rate of change of one quantity with respect to another. Some of the examples are: first, acceleration. Rate of change of velocity with respect to time. We use differentiation to calculate acceleration, to calculate the highest and lowest point of the curve in graph, or to know its turning point, the derivative function is used. To find the tangent and normal to a curve, and many more. Next is the notation for differentiation. Notation for differentiation, notation for the first, now note that this is the first differentiation. Notation for the first differentiation of function fx is we have three types of writings for the notation of differentiation. The first is Euler's notation. It's like this: dy or dfx. The second one, we have Leibniz notation. Leibniz says the notation for differentiation is dy over dx or dfx over dx. And we have Lagrange notation, y accent and f accent x. As you can see, the simplest one is this one, y accent and f accent. So in this chapter, we will use this one. Okay, but in further case, will know that dy over dx is the same with y. Note that differentiation can be done not only once. So I say that this is the first differentiation, yeah. But we can differentiate not only once, but several times. So the notation can be continued as y double accent, or maybe d square y over dx square for the second differentiation and so on. The second differentiation means another differentiation after the first differentiation. So later we will have the third differentiation, the fourth differentiation, and so on. Okay, so this is the notation for differentiation. Next, differentiate using limit. So as we can see that at the previous slides, we have the definition of differentiation as a limit, right? So we can use the limit to differentiate a function. Like example 1, use limit to differentiate fx equal to 2x plus 3. Okay, so let's write the limit first. H approaching 0. So as you can see, the formula is limit h approaching 0 from the function. So the function is f, not function, the change of y. Y over x. Okay, so this is the differentiation definition as a limit. But we have fx, right? We have fx as 2x plus 3. We don't know what is the f in the brackets x plus 8. So we will find the f in the bracket x plus 8 first. That means we have to substitute the x with x plus 8. And therefore, we have 2x plus 2h plus 3. Okay, so after we have the fx plus 8, we can continue the limit h approaching 0 from 2x plus 2h plus 3 minus in the bracket 2x plus 3 for the fx. Yeah, we can change the fx into 2x plus 3 over 8 over when you simplify, you will have limit h approaching 0 from 2x plus 2h plus 3 minus 2x minus 3 over 8, and then you will have limit h approaching 0 from x minus 2x is gone, 3 minus 3, 0, 2h over 8. And using the limit method, we can see that this one is 0 over 0 form. That means we have to factorize the function, but we don't have to factorize because we are in simplest form. So we only have to cross out the h. After that, we have 2 as the result. So I can say that y accent from the fx is equal to 2. And this is how you differentiate using limit. Next, example number 2. Use limit to differentiate fx equal to x squared minus 4x plus 3. So let's write the notation first. H approaching 0 from f x plus h minus x over h. For this one, I will try to find f x plus h first before we go to the limit. So I will have x plus h squared minus 2 times x plus h plus 3. Yeah. So when I expand this, we will have x squared plus 2hx plus h squared minus 2x minus 2h and 3. And therefore, we will get x squared. Then, cannot do anything with the final, so that is the final result. So after that, I can put the function of fx plus h into the limit. I will have x squared plus 2hx plus h squared minus 2x minus 2h and then plus 3 and then minus with the fx minus x squared plus 3 over h. Okay, next, let's by the function limit x equal to 0 from x square minus x square 0, negative 2x plus 2x also 0, and this one is 0, this one also 0, and then 3 minus 3 equals to 0 also, and you will have 2hx plus h square minus 2h over h. Yeah, okay. This is the simplest form that you can get from the function. As you can see, if we put the h equal to 0, you will get 0 over 0 again. So this is the coordinate form. You will have to factorize the function. To factorize it, you only can factorize the h outside the bracket. You will have 2x minus 2 after that, you can cross out the h and substitute one more time for h equals to 0. You will have 2x plus 0 minus 2, and therefore you will have 2x minus 2x and so on. And therefore, I can say that the y-accent equals to 2x minus 2 for this function. But it will be annoying if we use limit every time you solve a question, some questions. Yeah? So I will give you the method, the easiest way to differentiate a function. Yeah, first I will teach you how to differentiate a constant function. A constant function is something x equals to a number. When a number without variables differentiate, it will give us 0. Yeah, so example 1, find the differentiation of y equals to 5. Means you can say that y accent equal to 0. Okay, and then when you have fx equal to negative square root of 2 over log 3, you know that log 3 is a number, square root of 2 is also a number. We don't have a variables right here. That means y accent equal to 0. Every time you find a constant, the differentiation will be 0. Next is the differentiation of a linear function. Linear function is a function in the form of x to the power of 1. It's linear, so there are no fractions, there are no square roots, it's only x to the power of 1. So if you have ax, that means the differentiation of ax is 8. You can eliminate the x. Okay, the result will be only 8. Note that if the function contains an addition or subtraction, you can differentiate the terms separately. I will explain this later on the example. So example 1. For example 1, we have two terms inside the function. So we have 1 equal to 5x plus 1. Two terms means you have this and this separated by addition or subtraction. Take a look at the note. Note that if the function contains an addition or subtraction, that means you can differentiate the terms separately. Separately means you can differentiate this, and then after that you can differentiate the one. Yeah, separately. That means you have to think what is the differentiation of 5x and what is the differentiation of 1. Yeah, you cannot think what is the differentiation of 5x plus 1, yeah, because we can solve that separately. So the differentiation of 5x will be using this one, the linear form. It will give us only 5. And then the differentiation of 1 is a constant. Constant will give us 0. So the result for the y-axis will be 5. So this is the differentiation for example 1. And then example 2 is the same. Fx equals to negative 2 plus x. We have two terms right here. The first term and the second term. We can separate them. We can differentiate them. Not separate them. Differentiate them separately. First one and the second one. For the negative 2 is a constant. When you differentiate constant, you will get 0. And then tan x linear. Linear means you will get 10. So the tan of x equals to 10. Yes. Next is differentiation of quadratic polynomials for any power function. Differentiation of power function has a form of this 1 fx equal to ax to the power of n. Yeah, so the n can be any numbers. It's like 2, 3, 4, 5, 6, 7, or maybe decimal 2.5, 3 over 2 fractions maybe, or maybe square root of 2. I don't know. It can be any number. And the differentiation is a little bit complicated. It will be a m x n minus 1, x to the power of n minus 1. Yeah, but I will tell you the easiest way how to solve this. Note that function, if the function contains a multiplication or division, we cannot simplify the function one by one. Yeah, it's different with addition and subtraction. So if you have multiplication and division, you have to multiply the function first, or maybe you can divide the function first. So you will get a simpler function. Yeah. So example 1, we have y equals to 2x to the power of 3. Please note that we have power 3. Power 3 means it's not linear, and we have variables that means it's not constant. So we know that we have to use this formula. So the formula is a little bit complicated, as you can see, but the working is easier than you think. Yeah. So what you have to do is you have to write the coefficient, the 2, and then move the power to the front. You will have 3, so you will have 2 times 3, and then you add the variables one more time, and then you only have to subtract the powers with 1. Yeah, so differentiation in Indonesia in bahasa is turunan. Namanya turunan, guys. Turunan means powersnya itu diturunin 1. So, pakai bahasa Indonesia lebih enak ya, turunan kurangi 1. Jadi caranya adalah pangkatnya ke depan, terus pangkatnya kurang 1. So 1x will be 6x squared. There you go. And I believe that you already learned this in physics, so I will not explain more. Next is example 2. Example 2, we have this complicated function, but it only contains addition and subtraction. There are no multiplication, right? So we can differentiate them one by one. First is 4x5. 4 times, move the power to the front, 5, and then minus the power with 1, 4. For this one is 2 times 2x to the power of 2 minus 1 equals to 1, minus linear form, it will be 4, and constant will be 0. There we go. Okay, so the final result will be 20x4 plus 4x minus 4. Later, I don't want you to write this row, write that working. I want you to get the answers directly if the function is simple. Yeah, if the function is simple, I want you to get the answers directly without writing the first step. Okay, next is example 3. Find the differentiation of this one. So for this one, I have fraction. Yeah, fraction function. That means division. When you have division, you have to divide the function first. So before I differentiate the function, I will have to divide them one by one. 4x5 plus 2x squared minus 4x plus 5. As you can see, all of the function at the numerator have to be divided by square root of x, right? Square root of x means x to the power of 5. X to the power of half. So each of the terms have to be divided by x to the power of half. Therefore, you have x to 4, x to the power of 4.5, 9 over 2, 2x to the power of 3 over 2. If you remember, when you divide powers, that means you have to subtract the powers, right? 1 minus half equals to half. And for this one, we cannot do anything besides move the x to the top. When you move the x to the top, you will have x to the power of negative half. There you go. we only have one row of a function. That means we are ready to differentiate it. So to differentiate it, we have to use the formula of powers function, because we have powers of x. That means 4 times 9 over 2, move the powers to the front. 4 times 9 over 2. 4 times 9 over 2. I will write it one more time before I use the short method. Yeah. And then you have to minus 1. 9 over 2 minus 2 over 2. 7 over 2 plus 2 times 2 over 2. Move the powers to the front and then minus the powers. Half minus 4 times move the powers to the front minus the powers, then plus 5 times that half, move the powers to the front and then minus the powers. There you go. This is the result. The result is 18 x 7 over 2 plus 3 x to the power of half minus 2 x to the power of negative half, sorry, 35 over 2 x to the power of negative half. There you go. This is the f of x. Example 4. For example 4, we have multiplication. When you have multiplication, you have to multiply them first. When you multiply them, you will get x squared plus 2x minus 2 plus x 3. And therefore, differentiation will be 2x 4 plus 1. Okay, this is example 4. Next is chain rule, guys. When you have to differentiate a composite function, a function inside another, you have to use chain rule. Differentiation of fx equals to a times gx to the power of n is the coefficient a times the power n, and then minus the power by 1, and then times again with the differentiation of the inside function. Yeah, so we have two functions right here, outer function and the inside function. The outer function is fx and the inside function is gx. Step for chain rule. Yeah, not all the chain rule form are in this form to the power of n. Not all of the chain rule form like this form. Ada yang beda. So the step for chain rule first is you have to differentiate the outer function first. Yeah, the outer function, and then when you already have the answer, you have to times the answer with the differentiation of the inside function. Okay, so example 1. Example 1, we have this type of function y equal to 2 times 3x plus 1 to the power of 3. So usually you have this type of questions like 2x to the power of 3. When you differentiate this one, you will have 6x squared. Right? It's the simple function. But now, yang dipangkat di 3, there are another function that has the power of 3, not x, but 3x plus 1 to the power of 3. That means this function is a composite function. When you face a composite function, you have to take a look at the outer function first. The outer function is like this, 2x to the power of 3. So you only have to follow the rules for the power of function. The power of function is 2 times the powers have to be guys, 3, and then times with the function with the powers substituted by 1, right? So this is the normal method that we already learned at the previous slide. Yeah, okay, the normal method. But take notes that we are not differentiate x, but we differentiate 3x plus 1. We have inside function. Yeah. When we have inside function, that means we have to multiply our answer with the differentiation of the inside function. The differentiation for 3x is 3, and the differentiation for 1 is 0. Okay. So overall, we will have 6 times 3x plus 1 to the power of 2 times 3. And we have 18 times 3x plus 1 squared. Kita coba pakai bahasa Indonesia. Pakai bahasa Indonesia ini gini guys. Jadi kalau kamu mau turunin ini, ya N-nya itu sama dengan angka depannya 2 kali. Jadi 2 itu koefisien ya. 2 itu nggak pernah diturunin. Koefisien nggak pernah diturunin. Dia cuma ditulis doang. Terus gampangnya gini, pangkatnya cuma 1. Jadi chain rule itu tuh pangkatnya turunin dulu ke depan. Terus pangkatnya berkurang 1, jadi 2. Baru dikali lagi sama turunan dalamnya guys. Turunan dalamnya tuh yang ini. 3x plus 1 inside function. Gitu. Paham ya? Okay. Next. Example 2. Find the differentiation of this one. So I have half times x squared plus 3x minus 1. Maybe you think that for this one you can expand the powers first. You can expand the binomial first. Yeah. But for this one, x to the power of 7. And inside the powers we have x squared plus 2x minus 1. More complicated than the first one. Yeah. So I think you cannot expand it. Yeah, you can expand it, but you can solve it maybe several hours. Yeah, so instead of expanding, you can use the chain rule. To use the chain rule, you follow the steps. First, you have to differentiate the outer function. Outer function is this one. You see the function as the whole thing. Yeah, so half times 7 and x squared plus 3 this one is the same. Yeah. Don't differentiate the inner function first, but minus the powers first. Jadi sekali lagi pangkatnya ke depan, pangkatnya berkurang 1, baru dikali lagi sama turunan dalamnya times with the inner differentiation. Inner differentiation means 1 x squared up to x, 3x becomes plus 3, minus 1 becomes 6. So this y-axis is 7 over 2 x squared plus 3x plus 1 times 2x. Next is example 3. For example 3 we have y equals to 1 over 2x minus 5. And as you can see we have fraction. Fraction that means division. We have to divide them first. 1 divided by 2x minus 5, of course you cannot do it, but you can write it as 2x minus 5. We bring the 2x minus 5 to the top, that means to the power of 1. So as you can see we have some other function for 2x minus 5 to the power of negative 1. That means to differentiate it, we will follow the chain rule. So first, move the power then minus the power with 1 is 2, then times it with the inner function differentiation. And the simplest form is negative 2 times 5 to the power of negative 2. Obviously you can write it like this, 3 over 2x minus 5 to the power of 2. And next is this one. Have multiplication right here. If you have multiplication and you can multiply them, I suggest that you multiply them. Yeah, you have to expand. So you will have x squared and then plus 2x plus 3, and if you change the square root into powers, you have 2x squared plus 2 plus 3, and you have to change the square root into powers. When you see square root in differentiation, to change it to powers, always like that, otherwise you cannot find the differentiation. So as you can see, this one is also opposite function. So function x equals to move the powers in front and then minus the powers of 1, negative half. Do not forget we have inner function, that means we have to times it with the differentiation of the inner function. We have 4x. For this one we have plus 2, for negative 3 so we have this. There we go. And I think we can multiply the half and for x plus 2, yeah. So we have 2x plus 1 times 2x squared plus 2x minus 3 to the power of negative half. Maybe if the question is multiple choice, you can find the answer 2x squared plus 2x minus 3 There we go. Okay guys, already 30 minutes of video, so I think I should stop right now. Otherwise, you will be bored. So I think that's it for today. We will meet again in the next video. Bye guys.